You want to know what's crazy? The higher up we go, like when we fly in a plane, the colder it gets. Yet we're closer to the supposed heat source of the Earth, which is the sun. Now, we know that the closer you get to a heat source, the warmer it is. If there's a heat lamp 10 feet away from me and I start getting closer to it, the warmer it will get. Yet at an altitude of about 35,000 feet, it's about minus 40 outside. Much colder than the surface of the Earth. And the same goes for the bottom of the oceans.
So I always like to ask the question when I watch videos like that, what is this guy's point? Like, what is his metaphysic? What is he saying is the reality then? So I noticed he said the supposed heat source of the Earth, the sun. So do you think that the sun is not the heat source of the Earth? Then what is it? He's also saying that the Earth is not the heat source, right? He's trying to say that the center of the Earth is hot and it should be, then why does it get colder when we go closer to it by going deep into the water? So what's he saying? So what does he think reality is, you know? And if you read the comments, which is always a dubious thing to do with videos like that, is, you know, a lot of people are like, yeah, don't believe anything, the firmament, whatever, like just throw out shit like, you know, but what are you saying is the reality? Because they don't have a coherent, you know, idea. But anyway, it is a good jumping off point to talk about why that is, you know, why it is. I know he's dismissing all like, oh, people are going to say I don't understand science. That's because you don't, dude. But let's talk about that for a little bit. Why does it get colder as you go up higher in the atmosphere?
There's actually several reasons. I mean, one reason is that as you go higher, air pressure is decreasing, right? That's kind of a no-brainer. Air pressure is decreasing. So therefore, because it's decreasing, you have that unit of energy is taking up more space. It's spreading out. So it cools. That's just a common
As air expands, it cools.
It cools. Exactly. I mean, blow out from your mouth.
Yeah.
As that air is expanding, it's cooling. It's cooling.
So, versus.
Exactly. So
right.
so Superman could have super cold breath, I guess, by using that technique. But how about this little bit of information? As you go into the stratosphere, it actually gets warmer because the UV light is hitting the stratosphere, and that's increasing the temperature. So how would he explain that?
The temperature only goes down in the troposphere.
Troposphere, the lowest layer.
Right.
That's where we live.
But then you get to the stratosphere, and it increases because of the ozone is now trapping more heat.
UV's implicated in there.
Then you get to the next one, which is what, the mesosphere?
Is it exosphere?
No, exosphere is the last one.
Beyond.
And temperatures go down again. But then you get to the thermosphere, where it gets really hot. It can get to hundreds, thousands of degrees in the thermosphere, but it still feels cold because there's a difference between temperature and heat, right? So temperature is essentially the average amount of movement of each air molecule. But if you have very few air molecules, even if each individual one's moving a lot, that's very little heat. And if you were in the thermosphere and it's 1,000 degrees and you feel cold because there isn't a lot of air to transfer heat to your body, but you'll still be radiating away heat, so you will feel cold. Just like in space, if you're in space, it could be really hot if the sun's directly, you know, beaming on you.
Right. Yeah.
But without that, it's freezing because there's no air to transfer heat to you.
Like the corona of the sun is similar. It's got a very, very high temperature, like crazy high, millions of degrees, but very low heat.
Right. But the other thing about what the guy's saying is, doesn't it get hotter when you get closer to a heat source? Yeah, that's why Mercury's really hot. That's why lead will melt on the surface of Mercury. That's why Venus, also hotter than the Earth, there's also the runaway greenhouse gas effect there. Then the Earth is warmer than Mars, and then the outer planets are cold, and Pluto is an ice ball, right? So as planets get closer and farther from the sun, they get warmer. The closer planets are warmer, the farther planets are cooler. The difference in distance to the sun, assuming like it's noon and you're going straight up, which is another thing, you know, you're not always necessarily going towards the sun when you're going up in the atmosphere, depending on where you are. But let's say even if you are, it's insignificant. It's like 93 million miles away, average, plus or minus 1 mile. It's insignificant. So no, you shouldn't expect to get warmer just because you're getting hundreds or thousands of feet or even miles closer to something which is 93 million miles away. So that's just silly. Now let's go in the other direction. Why does it get colder when you go deeper into the ocean, despite the fact that you're getting closer, again, insignificantly, to the center of the Earth? That's a very simple answer to that question, because cold water is heavier than warmer water, right? So cold water sinks. It's heavier until you get to about 3 to 4 degrees Celsius. It depends on salinity, right? So it's variable. But at that point, the water begins like to crystallize, and so it gets lighter. And so that's why ice floats. So at the bottom of the ocean, it's going to be that, 2, 3, 4 degrees Celsius, because whatever the temperature is of water when it's at the heaviest. That's it. Cooler water is relatively heavier than relatively warmer water. Same thing with air. People say, what heat rises? Heat does not rise. Heat has no inherent tendency to move toward or away any gravitational field. Warmer air is relatively lighter than cooler air. So warmer air will move above cooler air, but heat itself just radiates or conducts in all directions equally. Right. So yeah, this guy just doesn't physics. He just doesn't understand what's going on. But which is in and of itself is like, okay, not everybody necessarily knows off the top of their head about the troposphere and the thermosphere or whatever, but you can find this information. It's pretty much readily available. But also, it's not that he's ignorant. It's that it's the logic he's using. Like, this doesn't make sense to me. Therefore, we can't trust scientists. We can't trust the powers that be. Because,
that's my take. That's what he was saying.
Because I don't understand this. They're wrong. Or maybe you just don't understand it. How about that? Maybe you don't understand the science. That's a far simpler explanation. But it is always interesting to start with that and then say, well, what does science actually say? What do we know about this? And it actually makes perfect sense once you actually understand even a little bit of the science.
And it's fun.